Okay, so this question here, Eliza has sketched the curve y equals 2x minus x squared. She has indicated 3 points on the curve, 0, 0, which is here, 2, 0, which is here, and of course then 1, 1, which sort of has been indicated there, 1 on the x, 1 on the y, so it's that sort of, it's actually the top of the curve there, yeah? Okay, so it says then show that these points lie on the curve. So actually show that they lie on the curve. It's all very well me pointing them out there on the diagram, but show that they lie on the curve. So all you've got to do is, for that, right, is look at the coordinates, and we can see that x is 0. So we can say, look, when x is equal to 0, let's see what y is equal to in this curve equation here. So if we put 0 in here, we'll have, obviously, it's obvious what it's going to come out to be, isn't it? We'll have that, which is equal to 0. So when x is 0, y is 0. So that point is on the curve. Tick box. Second one, when x is 2. Let's just show when x is 2, y will equal to 2 times 2, take away 2 squared, and when you work that out, 2 times 2 is 4, take away 2 squared is also 4, so you get 0. So that point's on there. And then when x is 1, y will equal to 2 times 1, take away 1 squared, which is equal to 1, so indeed that point is on there. So that's all you've got to do if they ask that, right? And in part B, it says, showing all your working, calculate the area of the region bounded by the curve and the x-axis. So basically what they want you to do is work out this area bounded by the curve, the area of this, right, and the x-axis. In order to work out the area, of course, we integrate. Okay, that's the idea here. So the area under the curve will equal to the integral of the curve, right, which remember now is 2x minus x squared, of course with respect to x, and the limits, right, because we do need limits when we work with the area. Of course the lower value is 0 and the upper value is 2, right, so you just look at where the sort of area starts and where it ends there, those limits on the x-axis, so 0 and 2, right, don't worry about the 1, that's got nothing to do with it, it's just halfway in between, isn't it, it's where it starts, where it ends. So if we integrate this, remember when you integrate it, you need to put a box. So that would be 2x, and then raise the power, 2x squared upon 2. And then raise the power there, that would be x cubed upon 3, of course. You divide by that power as well. 2, 0. And we can even simplify that. That would be x squared, wouldn't it? 2 divided by 2. Okay, they cancel. Take away x cubed upon 3, between 2 and 0. And what you've got to do then is, you need to put those limits in, right? So we start off with the 2, okay, and remember we have a big bracket, so put the 2 in here, so 2 squared, take away then 2 cubed over 3, and then take away then, always take away, remember, then enter 0, so 0 squared, take away 0 cubed over 3. So then we break this bracket out here, so 2 squared, of course, I know is 4, take away 2 cubed, which is 8, so 8 over 3. And of course then I get 4/3 for that. And that just becomes 0, so my answer is just 4/3. That's the area there. That's what this comes to. It comes to 4/3.